Hi, my name is Lucas, and I want to talk to you about the Ceylon type system. So let's start with a bit of exercise after lunch. Who here has ever been frustrated or angry with a compiler? Raise your hands. Okay, yes, most of you. Good, because I didn't know what to say if anyone didn't raise their hand. All right, so I'm not here to tell you tales of some kind of promised land where this never ever happens, but I am here to tell you about a programming language where it at least doesn't happen as often and where the compiler helps you more often than not. And this language is called Ceylon. I've been involved with it as a volunteer for over 4 years now. And I don't have time to talk about everything that's awesome in Ceylon, so I'm just going to focus on the type system and hope that you're curious enough afterwards to find out about everything else that there's also in Ceylon. But before we start, let's just take a quick look at type systems in general. So let's take some generic language you can pretend is JavaScript. Without a type system, you have a function here which takes some kind of argument, multiplies it by 2, and then returns it. And then a type system is when you take this code and add some information to it. For instance, you declare you can't have any kind of argument here. Num can't be a string, otherwise you could multiply it by 2. So this actually has to be, let's say, a floating point number. And also the function will return a floating point number. And now once you've added this information, you've made your code easier to read for anyone else. And you've made it easier to use, because if someone is using your function and they pass in, for instance, a string, then the compiler can tell them, actually, that's not how the function is supposed to be used. Please fix that. And if you make a mistake yourself, the compiler can correct you. For instance, let's say you heard somewhere that you can also multiply by 2 by doing a bit shift, shifting the number 1 bit to the left, and you heard that this is more efficient, so you try it out. And then the compiler tells you, actually, that doesn't work because you're dealing with a floating point number, and this bit shift trick only works with an integer number. And if you didn't have the compiler to tell you this, then you would probably only find out when someone calls your function with like 2.5 and very weird things happen. So in this case, the compiler helped you find this bug earlier. And in the Ceylon type system, there are 2 things which make it special and innovative, in my opinion, which are union and intersection types and flow-sensitive typing. So let's talk about those, starting with union types. The idea behind that is fairly simple. Instead of saying that a value just has a single type, like int, float, string, some class, it can also have more than one type, and it could be any one of those types. So for instance, you have a function here, which is declared to return either a document or a parse error. And before you can do something with the document, let's say process it or render it in a browser if it's HTML, you first have to check, did you actually get a valid document, or did you get some kind of parse error? And if it's a parse error, you have to deal with that and like show it to the user or something. Or you have a function which is declared to accept some kind of element and an optional priority. And this integer with a question mark behind it means that it's an optional type. It could be an integer or it could be null, like the default argument here. And that's actually a union type in disguise. It's just an abbreviation for integer or null, where null with a capital N is a class with only this one value, which is null with a lowercase n. So this can be this one special value null, or it can be any kind of integer number. And that's how null safety works in Ceylon. Ceylon is a null safe language. You can't have something like a null pointer exception or null reference exception or anything like that in Ceylon. If you have an optional value that could be null, then the compiler will force you to first deal with that possibility before you can run into any kind of problems. And on the flip side, if your function says that it can't accept null, then the compiler will not let anyone call that function with a null argument, so you're protected. For instance, this parse document function up here doesn't have to worry about getting a null string HTML because that's just not allowed. And nothing about null safety in Ceylon is actually a special case of the type system. It's just a bit of syntactic sugar around this more general feature of union types and a few other things which we'll see later. So the opposite of union types are intersection types. Instead of saying a value has one of these types, you say it has all of these types at once, which doesn't make very much sense for things like int and float. A value can't be both at the same time, but a value can have, for instance, 2 interfaces at the same time. Let's say you need the printable interface and you need the scalable interface, so you declare your function needs both of those, and then can only be called with values which implement both of these interfaces. And that's not a very convincing example. Actually, I had trouble finding a better one, because the truth is you don't use intersection types directly that much. They're a lot more important behind the scenes of the type system, as we'll see later. So this isn't a great example, but we'll see how they become useful. And after union and intersection types, the second big thing in Ceylon is flow-sensitive typing. So let's look at a language which doesn't have flow-sensitive typing. This is a bit of Java. And if you've ever written Java code, this should look a bit familiar. You have some kind of general value, like an object, and you want to do a stringy thing to it, like converting it to uppercase. And before you can actually do that, you have to first test, do you actually have a string or not? And then after you've done that, you also have to cast it to a string. So you have to repeat your type at least twice, if not 3 times, if you're also assigning it to a variable like here. And then you're allowed to use it like a string, which is, I think, a bit wasteful. And in Ceylon, you don't have to do that. So this condition down here is string means the same thing as the instance of string above. It's just a bit of different syntax. But after you have done this test inside of this block, which is only reachable if the value is a string, you can just say that the value has the type string now. Because you've already tested this, the block is only reachable in that case. So you don't have to cast anything. The compiler already knows that. And outside of the block, it's a generic object again. And this might look a bit magical at first, but I promise you, once you start getting used to Ceylon a bit, this will become really natural, and you will really be annoyed when you have to go back to Java and do explicit casts all the time. So that's a simple example of flow typing. And a more complicated one is if we go back to null safety. So here we have a program with some optional value. In this case, it's the first argument of the program, which is usually string. But if the program wasn't called with any command line arguments, then this is null. And you check, does this value exist? So is it not null? And if that's true, then you're allowed to print the uppercase version. And you know that this will not blow up with a null pointer exception because you've already tested that the value is not null. But I said earlier that there's nothing special about null safety in Ceylon. It's just a bit of syntactic sugar. So what does this actually mean? This exists condition actually means, is it an object? And now earlier in the flow-sensitive typing example here, it looked like we had just taken this type from a condition, string, and said that this is now a string. But in that case, here we would say, after the condition, is arg an object? We would say that arg is now an object. How do we know that it's actually not just an object, but it's a string? And the answer to that is that the compiler takes all the information it has. So we already knew that it was an optional string, and we also know now that it's an object, and we can take both of these informations at once because we have intersection types. So actually the new type of the argument in here is optional string intersected with object. And now we have a type expression which we can start to simplify. So the compiler does all this for you. I'm just walking through it now to demonstrate how the type system works, but usually you don't have to worry about that. But what the compiler now does first is optional string means string or null, as I already mentioned. And if you want, you can also write this in a more mathematical notation, because these union and intersection types actually work like union and intersection operators on sets, if you think of your types like sets. So the type string can be thought of as a set of all possible strings. Then you have the union of string and null intersected with objects. And if you write it like that, you can perhaps see that you can also apply a distributive law here and pull the object inside of this parenthesis. And then you have a string intersected with object or null intersected with object. And the exact same thing we can write as a type again, which looks like this. And now we can simplify each half of that separately. So string and object is the left half. And string is a subtype of object. So string and object is the same thing as just string. And we can ignore the object. It doesn't add anything. And the intersection of null and object is special because null and object are two separate classes in the type hierarchy. So the general type hierarchy in Ceylon works like this. There's a top level type called anything, and everything is a subclass of anything. And then you have below it, on the one side, you have null, and on the other side, you have object, and below object is everything else like int, float, string, all your own classes are below object, and null sits next to object. So there aren't any values which can be null and object at the same time. So this is actually the intersection of two disjoint sets. So there aren't any, this is a type which doesn't have any real instances. So as a type, we call that nothing, and it acts like the empty set. So taking the union of the set string and the set nothing, which is actually the empty set, is just the same as taking the set string directly. And that is how the compiler knows that after this condition up here, you now have a non-optional string which you're allowed to call uppercase on. And I haven't actually checked my watch, but I think I'm out of time now. So I don't have the time to tell you about all the other stuff that's awesome in Ceylon, how we have tuple types, which are actually linked lists and all that stuff. So if this sounded interesting to you, then please talk to me later in the break or tomorrow, or visit our website. We have a quick 50-minute introduction or a longer tour. Please take a look at that if it sounded interesting. Otherwise, thanks for your attention.